Now we would like to increase the variables in the linear equation, as this is the example of linear equation in one variable. Now we are extending what are the linear equations in two variables. So for this I am just going to write one linear equation in two variable. It's like this. If I write here 2x minus 3y is equals to minus 1. This is the linear equation. Yes, because here variable x has power 1, here variable y has the power 1. It is the equation because it has two sides. It has algebraic expression. It is equated with some particular value. So it is what? It is the linear equation. Absolutely right. It has two variables x and y. So linear equation in two variables. As in class 9th, the topic was coordinate geometry. You know how to plot a line for the given linear equation using the coordinate geometry. What is coordinate geometry? When we separate a plane by drawing two lines, one horizontal line is known as x-axis, one vertical line known as y-axis. Where x-axis and y-axis intersects, it is known as the origin. This part is known as positive x. This part means from origin to right side of x. From origin to left side of x is known as negative x. Above to x-axis is the positive of y, and below to origin, that is below to x-axis on the y-axis is the negative of y. So when we plot two axes in a plane, x-axis and y-axis, plane is separated into four identical parts. This is the first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. First quadrant is the combination of both plus x and y. X is positive, y is positive. Second is x negative, y positive. Third, x and y both are negative. And the fourth one is x is positive and y is the negative. The value of x in the coordinate geometry, which I am revising you, is known as abscissa, and the value of y is always known as the ordinate. So when we separate a plane in four parts, each is known as quadrant. Each quadrant has its own sign, abscissa sign and ordinate sign. The value of y on x-axis is always 0. Value of x on y-axis is always 0. So that's why the point of intersection of x-axis and y-axis is known as 0, 0. So if I ask you 1, 0 where lies? 1, 0 lies on the x-axis. If I say 0, -7, it lies on y-axis. It doesn't lie in any quadrant. In the quadrant, first quadrant what can lie? If both signs are plus. Second quadrant, first is negative, second is positive. Third, negative, negative, and fourth is positive, negative. So it is the introductory part, how to plot the graph. Now we will explain that how to plot the graph of linear equation in two variables, number 1. And with the same help, we will tell you why a system of linear equation in two variables may have unique solution, no solution, infinite solution, or a single graph has infinite number of set of solutions. This is the target. So if I ask you that 2x plus 3y is equals to 5, it is a linear equation in two variables? Yes. Then how to find the set of solutions before draw the graph? To find it, there are two ways. Way 1, we can express x in terms of y, or we can express y in terms of x. So it is always advisable to express that value so that the denominator should be a very some kind of number easily can be divided. So here 2x is equals to 5 minus 3y. X is equals to 5 minus 3y upon 2. Why I have taken here 2? Because division by 2 is quite comfortable in comparison of division by 3. So this is what? This is the division of, or you can say we have expressed x in terms of y. One more thing here, very mandatory to understand, what is the dependent variable and which is the independent variable. Here I will assume, I will select, I will opt the values of y. So y is independent variable, and whatever value of y, if it is fixed, automatically the value of x is bound to come. I cannot change the value of x if value of y is already accepted. So y is here independent variable because I will substitute, I will choose the values of y. Automatically x will come. So x is the dependent variable because x is depending on y. If it is not so, I am going to change like this, that it is like this: 3y is equals to 5 minus 2x and y is equals to 5 minus 2x upon 3. In this case, I have expressed y in terms of x. So here I am bound to choose the values of x. So here in this position, x is the independent variable and y is the dependent variable. Initially in the system of linear equation, anyone can be dependent or anyone can be independent. This is clear that what is the linear equation in two variable and which can be expressed. We can express x in terms of y or we can express y in terms of x. There are two things. The third number, which is dependent and independent, has made clear to you. Now a big question comes, that how many set of solutions this only one line has. A line can pass through infinite number of points, as you have plotted many lines even in your rough notebook or in your graph sheet. Whatever point line is taking in whatever point line is taking in its path is the solution. How many points lies on a line? Infinite points. So this is the reason graphically that every line, every equation in two variable goes for a drawing, a plot the graph, is always having infinite number of set of solutions. If I draw 2-3 points for this part or this part, line will come same, line will not come changed. Reason being because I am going to convert both of them from the same position. So I am plotting a table which is showing the set of solutions x and y. You can see here, if I opt y as 1, suppose y I am opting 1, if y is 1, so x will be automatically 1. If I am taking y as 3, suppose y is 3, so this portion 3 3s are 9, minus 9 plus 5 minus 2 divided by 2 minus 1. So value of dependent variable is coming like this. If I opt y as minus 1, I am getting the result 5 minus 3 into minus 1, that is plus 3, 5 plus 3, 8 upon 2, 4. How can I check whether these three set of solution I have taken is right or wrong? We are going to plot its graph, and if line is coming straight, then automatically I must understand, yes, the points we have taken, we have chosen pair which we have framed are correct. So for this 1, 1 is this point, 3, minus 1, 1, 2, 3. X is 3 or abscissa is 3. This is what? It is minus 1. 3, minus 1. This is the value position of 1, 1. This is the position of 3, minus 1. Fourth is, the second's position is, first is 1, 1. Second is minus 1, 3. So we are changing this position from here to minus 1. And suppose this is 3, say this is minus 1, 3. Second, I have changed because I have swapped the values in the previous. 4, 1, this is 3, this is 4, this is 1. 4, minus 1. This becomes 4, minus 1. X is 4, y is minus 1. Both are positive in the first quadrant, negative positive in the second quadrant, positive negative in the fourth quadrant, and I am joining showing, and this become the graph of the equation 2x plus 3y is equals to 5. So what conclusion is coming? The graph of the line 2x plus 3y is equals to 5 is passing through infinite number of points. Hence, whatever point the line is following is its solution. As I have taken only 3, one can take infinite number of set of values of x and y. By assuming the value of y, there will be a fixed value of x. So what we can conclude? We just conclude that if we have linear equation in two variable, it means that here it is possible to express x in terms of y or y in terms of x. Here it is possible to draw its graph. It will cut somewhere on x-axis. On x-axis, how to find at what point it will cut on x-axis? To cut on x-axis, you put y0. To cut y-axis, put x0. And in the next, we will tell you the system of simultaneous linear equations.